In geospatial research, the most important component is the communication. And when you've done your analysis, how you want to communicate your results, and the maps are playing an important role. So how to develop static maps and what are the design parameters you need to consider. This is the topic today I'm going to be talk about. The core idea behind this presentation is usually the GIS and remote sensing, which we normally think end with analysis. No, they do not end with analysis. They end with the communication, how you communicate your results and your hard work while collecting the data, building your analytical models. So most important component after that is how you communicate your results. Communication takes different forms. How do we communicate spatial results? We can use the thematic maps for the research journals and the posters, figures for the research articles, technical reports, post atlases, interactive web maps, dashboard story maps, and decision-making tools. So today I'm going to be talk more about how to develop the thematic maps. So how we define static maps. So there are some core characteristics which we need to be understand. They have a fixed message and with a controlled narrative, and there is a curative interpretation that needs to be communicated with a strong visual hierarchy of the information. Well, in case of the design principle, static maps are arguments, not decorations. I will explain you what is the difference between these two words are. As for other core requirements, every element must support the research question, and consistency matters more than creativity. So overall, we can divide the preparing static maps into three phases. The first one is planning and conceptual design, which is also a thinking process. So these are decisions, not software steps. So what you need to do while you are thinking, determine map purpose and production requirements, audience, media, color size, and those kind of things you need to be think about it. And then you need to decide which map elements are needed for that purposes. So for example, legend, title, north arrow, some additional information, description about those kind of things. You need insert maps, you need a zoom in subset of the map. So those kind of things you need to decide and establish a hierarchy of these map elements. So within the map, you want to decide how you want to overlay those layers with each other and choose the special parameters. So what scale you want to do and projections and how the map look like and which map projection is better and suitable for this kind of data set. So everything here can be done without opening ArcMap or ArcGIS Pro. So this is a thinking process. Phase two, which is more related to the visual design and cartographic choices. So these affect how data is visually communicated. So when you're designing the maps, so choose data classification schemes or methods carefully. Your symbologies also matter. You have a single ramp of color or you have a bivariant color. So those kind of things you need to be decide, and the sketch map layout and the orientation you want the landscape or portrait, or you want a one map, or you want it two or three maps on a figure, and then you want to decide which one is your primary map, which is a map locator, which one is a zoom in to show some details of some area which is very congested on the map. And this is where cartographic theory matters most. Phase three is basically your map production and how you're going to be export and deliver those kind of things. It's basically you are doing the stuff with the help of the software and preparing your draft map layout, whatever you have done in the first two steps. and then you want to be using the software to perform these kind of things. Refine your map layouts and having a visual balance, create final maps and publish for the intended users. So this is the third step, which where you can see your you have a static map ready for the communication purposes. So now I'm going to explain you this whole map planning with example. And our overall, if we want to see the steps, we have first stage, we need to define the purpose of this map and the questions related to this research work. Those you want to be going to be explained with the help of those maps. So identify what special map patterns or relationship to show. For example, the study I'm going to use is the WASH study, with water, sanitation, and hygiene data. And in that case, we need to have study area, prevalence, and odds ratios. I will explain in the next slides. Second thing is you need to determine mapped roles. So there are three different roles we thinking in this set of maps. So we have a context and the descriptive and analytical maps. So they have three maps which I'm proposing for this example, and then need to plan. So planning is more sequence of stories, so logical flow, how you want to make those three maps, how the flow look like, and each map builds on the previous one. So the context will be first you describe the study area, then you want to explain your variable, then finally you're moving towards your analysis or outcome based on the data set you have. Second to last one is design. So there are design considerations which we already discussed. So you're going to be pick those parameters, and then finally using in a way or more meaningful way of the classification, which I will explain you the difference uh, of different classification and the readability. And finally is putting all these things together, integrate maps, ensure map complement each other, highlight any patterns and findings you want to be doing that. So how we determine the map role? This is one of the piece which from the previous slide. We have three different maps. So context and the descriptive and analytical. So I'm going to explain you this one with the help of an example where you want to see. So this is the data set based on a multiple indicator cluster survey. And in Balochistan, there are 36 districts. So the data is represented by those district levels. So I pick that information and aggregate the number of households having improved wash, in other words, access to that improved drinking water as sources and access to the sanitation facilities. So these both together, which is called wash. You can see the detail about this variable, but this variable I'm using to show you how those static maps can be prepared. So in this case, you can see the first column is the total number of households. They will be like from the survey. And then out of those households, how many households having access to the improved wash services. So that's a percentage you see, and descending order from the maximum to the minimum, which is 12% in the lowest level. You can see from ranging from the 96 almost in the first row. And then the next column is next three columns are basically outcome from the logistic regression, where we're showing the odd ratio and then the lower and upper limit of those odd ratios with 95% confidence interval, and then the p-values show the significance of values in the p-values value using those odd ratios. So these are the information I want to show. So the prevalence, I want to map this information. I want to show the odd ratios for at the district level. So that's our plan. But before that, I just want to create a context. So I need a study area map with a little bit more detailed information to before to apply that prevalence and odd ratios, have some background information. So here is a map where you can see, which is normally we call it a study area map, but which establishes the context. and shows some information. So in this case, we are using the population proportions. And you can see the population proportion 2% up to 2% in 17 districts. So 17 districts have not more than 2% of the total population of the Balochistan. And if you see there's only one district in the highest category, which is 8.1 to 17.4, it means 17.4% is the total population of the Balochistan living in Quetta, which is you can see in the map. So that's the way those information we want to show with the population, the proportion distribution across those 36 districts, which is important to understand how the which area the more population and which is less, and those can context with your next analysis. So the second map is more descriptive. In other words, we are using the the prevalence, wash prevalence. So in other words, our dependent variable, how they are distributed in terms of the percentage. And you can see there are some percentages like the lower 80% and 95%, they are high prevalence. It means these areas have a better water and sanitation facilities together as compared to the other areas where you can see they have a low value. So this purpose of this map is basically to establish the descriptive and some dependent variables, the distribution of the dependent variable across our study area. So the next map is basically the important piece, which is we're talking about analytical map and how our regression results, which is odd ratios, adjusted odd ratios, we are we want to display with reference to the Haran district, which is basically we choose like based on the percent prevalence value, which is about the 50%. So we want to see the with respect to the Haran, which districts have a better odd ratios or better access to the watch for services or lower than that. So in reference to the Haran, this Haran district can be changed with respect with any other district. Maybe if you want to see with respect to the highest prevalence one, like which is the Quetta, and then you want to see what are the odds are when we compare with other districts with this reference district. So this is the way you can see all three different roles. So when you're preparing the maps, static maps, you want to be have some plan, and then you want to be making those maps using the same templates, repeating them, and all those cartographic rules, color schemes with labels and different elements where you want to see those things and color schemes. All these things are important when you're providing, and it looks should look like a set of maps when you are talking about all three maps will be looking like they're developed by using the same template and by the same person in that case. So now I want to talk about the second piece of information, which is design considerations. So when we talked about the consistent projection, boundaries, symbols, clear legends, and color schemes, so those kind of things. And the second set is meaningful classification of the data sets we have and maintain the readability of that. So I will give you some examples how these two things will be meaningful in terms of the static maps. So this example is where you can see the consistent projection, and the boundaries are almost like you see the national and like provincial boundary, and then with respect to the health region boundaries. So those are consistent. Legend is clear, and they have interpretation in the caption. And color scheme, you can also see the meaningful, like the shade will tell you where the situation is based on the indicator better or not better. So those colors are indicating accordingly. It's not like something is very better and we're using the red or dark colors which are representing the opposite situation. So we need to be use appropriate color schemes according to um, the information we have. On the other hand, uh, when we have a map design and color schemes, so here is the example of the four maps from the one research paper, which can give you the idea how they are consistent in the color scheme using the so four different variables. We have primary school children attending private schools. We have a population 10 plus literacy rate. Then we have a net attendance ratio, and then we have the literacy rate for 15 to 24 years of population. And now you can see each map, each figure has a two maps. One is showing the like the most latest prevalence or percentages. So literacy rate in this case, you can see on the map, top right map, it's showing the literacy rate, and it's increasing interval. And then on the second map, which is more colorful, which showing you the change over the time frame, where the change in the literacy rate is positive and where the change in the literacy rate is negative. So there are some districts which shaded orange color or light and dark orange color, they show the negative growth over a certain period, like 6 or 7 years period. The literacy rate, instead of increasing, they're decreasing in this area. So we need to be use that kind of information, a static map to show, and that is a consistent because now the indicators are changing. So, but we have the same strategy to show that information, so reader can be easily interpret that maps. So that's the main plan is in this case. If you want to see those examples, what's the meaning of consistent symbols and map more color schemes when we're using it. So in terms of meaningful data classification and maintaining the readability, there are few more examples you can see. Here are four different kind of maps. You can see one is a study area map and showing the comparison between the different situation, and then we have a distribution of the percentages, and then the next map is where we have the cross tabulation between the two variables. Those are each variable have two classes, so there are four combinations. We are showing the four combination in those cases where if the classes are above and below, so it means there will be four combination where will be above, above, and above, below, 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 and below, above. So those combination, how you want to show the any like the mismatch between the two variables, how they're showing it. So that's another set of examples where you can see you need a consistent color, you need some classification approach need to be varied according to the nature of the data and variables you have, how you want to see. So they have a variety of examples. You have a percentage data and percentage. You have also percentage, but you have also percentage, you change. You can also want to be sure that change information. You have some variable, we want to see the proportion of the out of total population, or you want to show the percentage of the like population density. In other words, you can show that, and then when you have a two set of variables and you want to show them, so you have a bivariant or cross tabulation approach which you can use it. So there are different ways to map the data sets for the purpose of your research. You heard the word classification scheme and methods frequently in this presentation. So here is an example where you want to see. So there are four maps of the same study area, same data sets, same variable, in other words, so using different classification methods. So first two maps on the top, you can see they have five classes each, but the class interval change. So first one is 12 to 35%. The other map is 12 to 29% is the range of the first category. How it's possible? The first one is using a quantile classification where all the 36 districts are arranged into five groups. So very close to the five groups, so they use that the range is determined based on the number of 6 or 7 districts from descending rank after ranking them from low to higher end. So they will be like group in that way. But when you will using equal interval, so in this case, they have a range from lowest to the highest percentage, and then that range is divided by the number of classes. So in this case, we have a 5 classes. So now the interval is defined. So that interval is repeated. So cutoff value is depending on the interval. and how much. They are not talking about the count of the features or the polygons or districts. They're talking about the cutoff value determined based on equal interval. Okay, so now the next example is between the equal interval examples will be the number of classes. So if you use the classes, 5 classes versus 3 classes, you can see the interval is also changed. So in this case, the interval is changed from 12. Now we have a 12 to 40% is the first class, and which when we were talking about the 3 classes. Okay, so next example is my favorite one, which is called standard deviation. So we have, if you recall that table when I was showing you, you have a prevalence of wash access to the wash services, and in terms of the percentage, so the lowest percentage to the maximum. We use the standard deviation. So standard deviation is the middle class is basically representing the mean value is within that class. So where is minus zero point 0.5 standard deviation to plus zero point 0.5 standard deviation, including the mean value of those percentage of improved wash services at the district levels. So there are 12 districts which fall in this range. So there are 11 districts, they have less percentage, and then we have a 9 above that range. So then we have is 1 point, like we have zero point 0.5 to 1.5 range, and then 1.5 to and above standard deviation range. So this tell us the data distribution, and with the help of some statistics, which makes a little bit more meaningfully. We don't want to be using the classification bias. So this is the way we can see what data is talking about and how those things can be seen on the map. So this is the different ways you can show that example. So when you're planning to make some static maps or thematic maps, you need to be consider what classification method is appropriate for your data set and is more meaningful. It's not for the decoration, it's for basically for your argument. That's the things you want to be keep in mind while you are designing these kind of maps. So this is another example which I already discussed. I just want to give you example how normally you want to be doing those cross tabulation maps, and where you have a two continuous variables, but you will be able to divide them into above and below a certain value, which is your cutoff value, and then each variable will have two classes, and that two classes will, when you want to be mapped, so you will prepare a new variable which will have four scenarios, and those four scenarios you can display on your map by using a different combination, and depending on your variable one and variable two. So for example, crime rate high and crime rate low, and then you have a educated people above a certain threshold or below the threshold. So you want to see the combination between the crime rate, high crime rate with a low education or high education. So those areas you can see, understand those kind of things. So this is the way we have in this example healthcare accessibility with the 65% population 65 and above, and then we categorize them according to the provincial or some other cutoff values to show the two classes, and then crosstab between two classes. This is another example where we can use a classification method. So all the discussion we have, so decision framework, when to choose static map. So we can use static map or thematic map. The story is a singular, the audience is expert, you have a specific kind of audience in your mind, and you want to be comparability across figures matter, and reproducibility is critical in those kind of things. So the bottom line is, if the data are static, one-time information is not regularly changing every month or every year, until unless they have a repeated survey. That's a different scenario, but in most cases, if this a survey data is a one time, or census data is be 5 times, after 5 year or 10 year, depending on which country census data you're talking about. But those are the example of the static data sets, and then you want to see the what message. If the message is fixed and the static map is often the better than as an interactive map. So at the end, a good map answers a question, and bad map shows everything, and an unnecessary interactive maps often hides the answer behind clicks. Thanks for watching, and if you have any question, let me know.